Next 45 minutes, what I'd love to do is share with you my journey that I've been on since 1999, which is studying high-performing technology organizations. So these are those organizations that had the best project due date performance in development. They had the best operational stability, reliability, and availability in operations. They also had the best posture security and compliance. And so our goal was always to understand how did these organizations make their good to great transformation. Why? So that the rest of us could replicate their amazing outcomes. And so there were many surprises on that journey over the last 15, 16 years. But perhaps the biggest one was that it took me straight into the heart of the DevOps movement, which I think is urgent and important, of which the Jenkins user community is one of the most central communities for that. And so to Kasuke and the entire Jenkins user community, my congratulations to you for everything that you've achieved over the last 10 years. So first off, congratulations to you. It has been breathtaking to watch. And the reason why I think that is so important, in other words, the continuous delivery pipeline, is one of the most prerequisite practices in order to make DevOps happen, which I think is urgent and important, because I believe that it solves the most pressing business problem of our generation. The last time we've seen a transformation this large was when manufacturing was transformed during the 1980s due to the application of lean principles. So over the next the remainder of this presentation, I want to share with you three things. One is a brief description of why I think DevOps is so important. Two is, maybe more importantly, the how of DevOps. What are the principles and practices that are allowing organizations to do tens, hundreds, or even thousands of deployments per day while preserving world-class reliability, stability, and security, which is something that we didn't even think possible 5 to 10 years ago. And then I want to share with you what I've learned over the last couple of years, learning about how large, complex organizations are adopting DevOps. In other words, DevOps isn't just for Google, Amazon, Netflix, Twitter. Instead, it's for organizations like Verizon, the US Department of Homeland Security, amazing organizations that are achieving the same sort of miraculous technical outcomes that we typically only saw in the unicorns. So in terms of the why, it's really about this downward spiral that we have started to see around 2005 that would happen in almost every technology organization, independent of industry vertical, independent of company size, profit, not for profit, left unchecked without something like DevOps would lead to horrendous outcomes, not just for dev, test, and operations, but also information security and ultimately the organization that we served. And one of the, I think, the best descriptions of one of the major contributing causes is what Ward Cunningham called technical debt. Right, so he coined this very much in the context of code 11 years ago. He said, technical debt is that which we feel the next time that we want to make a change. And so I think it's just a marvelous, almost poetic phrase, because in my mind, it evokes this image, right? It is the accumulation of all the crap that we have allowed into the data center over decades, each time made with a promise that we're going to fix it when we have a little bit more time, right? And that there's never enough time. The way that life works and the way that human nature works is that there's always something more important that will put this on the back burner. So this, left unchecked, will eventually turn into this, right? And so this happens every time that we check something let something go into production without automated testing. It happens every time that we make manual configuration changes to the environment. It happens every time that those changes aren't in version control, right? All these things contribute to the downward spiral. And so what are the, so it happens at the end of every project that we take shortcuts for, where we don't focus on the non-functional requirements. And yet there's also another downward spiral that's a little bit less obvious, but even more insidious and destructive, which is that deployments start taking longer. So think of an application that you've been associated with that used to take 5 minutes to deploy, so it's taking an hour, so it's taking a day, so it's taking a weekend, so it's taking a week, right? I've had firsthand experience of an application that supported a $3 billion a year ad display business that took 6 weeks to deploy. It involved 1,300 manual, extremely error-prone steps that took 6 weeks to get through, tying up 300 to 400 people throughout the dev, test, operations value stream. And so when that happens, this is when we start to set the intertribal warfare that can exist between dev, test, and operations. So here's our friendly developer who checks something into the code repo at 5 p.m. on Friday, right? And they will high-five each other in the parking lot because they made the date, but not realizing that they've set the entire data center on fire, and now everyone has to work all weekend to try to get things running before the markets open on Monday. And so at this point, no one's achieving their goals. Deployments are starting to take longer. Features are taking forever to get to market. We have an ever-increasing number of sub-1 outages happening in production, and operations becomes increasingly buried with unplanned work, increasingly unable to pay down the technical debt that everybody knows, which is required to actually help the organization win in the marketplace. Does And the inability to do that year after year eventually leads to a sense of hopelessness and despair, right? We feel like we are powerless to change the outcomes, and no matter what we do, we are forever doomed to get the same outcomes over and over again. And there's no worse thing that we can do to a fellow human being than put them in a situation where they can't control their own outcomes. And so, by the way, does anyone here have a friend that can resonate with at least some elements of the story? Right? So the good news is you're not alone. But the better news, right, is that we now know that there's a better way, and that no community has known this longer than the Jenkins community, right? And so we would call this practice now that we call DevOps, right? It is this umbrella of practices that were pioneered by organizations like Google, Amazon, Netflix, Twitter, and so forth, the unicorns. But DevOps is not just for unicorns, it's for horses too. There are large, complex organizations that are adopting these same principles and practices and getting the same sort of outcomes, which is just fantastic. And so there's no doubt in my mind that what DevOps is doing for dev, test, and operations, even information security, is transformative. And to the point where I think historians will look back 10 years from now and say, the way we work with technology changed around now, plus or minus a couple of years. And then when they ask the question, where did DevOps come from? I think there's going to be a tremendous degree of unanimity that said it came from here, right? The famous John Allspaw, Paul Hammond presentation that was given at the Velocity conference in 2009, about 30 miles north. And they gave this astonishing presentation, of course, that said they were doing 10 deploys a day, every day, as part of their daily work at Flickr. And so by all first-hand accounts, the people who were there in that room knew that they were in the presence of something historically significant. I have to admit with some shame that that was not my reaction. My reaction was more like this: 10 deploys a day, right? That's impossible. And even if it were possible, it sounds reckless, dangerous, ill-advised, and to be honest, it sounds immoral, right? Because what good person would want to do 10 deploys a day to someone else when they didn't need to, right? It's just not polite, nor is it nice. And yet I now believe that whether we're in dev, test operations, especially information security, if we can't create around us a system of work that can enable people to do deployments on demand, then we as a functional silo risk irrelevance, and ultimately the organization that we serve risk irrelevance as well. And one of the things I love about DevOps is it is fundamentally a community of boundary spanners. And you can see this even in the first presentations around DevOps from Allspaw and Hammond. One of my favorite quotes, though, comes from Theo Schlossnagel. This was also at the Velocity Conference in 2011. He said, DevOps is a terrible term. It's incomplete. It's prone to misinterpretation. So what would Theo call it? He would call it star ops, or maybe more pedantically, dot star ops. Or maybe even more pedantically, it's every department ops. Because essentially what he was asking was, where's information security? Where's testing? Where's product owners? Right? Essentially, that's the entire village that we need to mobilize in order to get these amazing outcomes of fast deploys, right? Short lead times, and great reliability, right? And so one of my favorite quotes that I've learned on my journey came from the Software Engineering Institute at Carnegie Mellon University. And they taught me many things, but the one quote that I think about all the time is this one phrase: high performers in every profession always accelerate away from the herd. In other words, the best are always getting better. And that's absolutely happening in the DevOps space as well. Back in 2009, we thought 10 deploys a day was shockingly fast. These days, it's considered mediocre, right? And as an evidence point, in 2011, John Jenkins said they're not doing 10 deploys a day. They're doing one deploy every 11.6 seconds, right? So that's a mean number of deploys per day of around 10 to 15,000 per day. Right, and just shows that, so what is a deploy, right? Of course, you know that it could be a code commit by development, it could be a configuration change in the environment, it could be a feature release going live through the toggling of a configuration flag, a feature toggle. All of those constitute a deploy. And what's even more amazing, right, is that Amazon continues to ramp up its number of deploys per day. Ken Exner earlier this year said they're not doing one deploy every 11.6 seconds. They're doing 50 million deployments per year. So you do the math, that's about 136,000 deploys per day. Right? So it just really shows us that the best are always getting better. And I'll speak more about the deploys per day metric later today. So this desire to make changes when our organizations need it most, I think really show the why of what's driving DevOps improvement, right? The goal is to be able to make changes when our organizations need it most. So it's not just the unicorns who have this need. It's our service providers, it's financial services, it's retailers, it's manufacturing, it's government agencies, it's higher education. And so what's astonishing to me is like these organizations at the bottom of the list, right, are those organizations or industry categories that are considered to be most conservative in adopting things technology related. So why would they be adopting DevOps when it's considered so radical? And I think the answer is that after benchmarking over 20,000 organizations over the last 3 years is because that the business value of adopting DevOps patterns is even higher than we thought. So I've had the privilege of working with a gentleman named Jez Humble. He's the co-author of the Continuous Delivery book. And we worked with Puppet Labs to do what we call the State of DevOps report. And what we learned was that high performers are massively outperforming their non-high performing peers. That we know that high performers are doing 300 times more frequent deployments, right? And more importantly, their lead time to go from code committed through the test cycle, through the deployment cycle, to successfully running in production is 200 times faster. Meaning high performers can execute that in minutes, whereas lower performers might require months, right? So 2 orders of magnitude difference. So not only are they doing more work, they're getting far better outcomes. When there is a production deployment, they're 60 times more likely to succeed without causing a Sev1 outage, a service impairment, a security breach, or a compliance failure. And when something does go wrong, because Murphy does exist, right, they can fix it 168 times faster. In other words, the mean time to restore service is 168 times faster. And so the reason why this was such an important finding for us was that it showed us, it gave us empirical evidence that you could go faster and be more reliable at the same time. In fact, if you look at if you want these sort of reliability profiles, we have short mean time to repair, we need to do deployments, smaller deployments more frequently. Another hallmark of the Jenkins user community. There was another thing that we found last year that was absolutely startling, which is not only did high performers have better technology performance or IT performance, as measured by change success rate, mean time to repair, deployment frequency, and deployment lead time, we found that those high performers were twice as likely to exceed profitability, market share, and productivity goals. And for those nearly 1,000 organizations that gave us a stock ticker symbol, we found that those high performers had 50% higher market cap growth over 3 years. So I'll be the first to admit, this is a somewhat absurd finding, right? This is almost unbelievable. In other words, how is it that how a sysadmin or a developer works in their day-to-day work, how could that possibly impact the bottom line, let alone stock price? And yet, if you believe that increasingly how all organizations create value for its customers is increasingly reliant on the technology value stream, then maybe being orders of magnitude better than their competitors, will show up. And so I find that to be actually a very highly satisfying finding. Am I making sense? So good? Awesome. So I guess the real point here is our work matters. So if there's one book that I would recommend to everybody, it would be this book. This is actually my favorite book that has probably had more impact on my professional career than any other book. It's called The Goal. It was written in the 1980s. It's a novel about a plant manager who has to fix his cost and due date issues in 90 days, otherwise to shut the plant down. And so this book has been integrated into almost every mainstream MBA curriculum over the last 20 years. And so when I read this book, this must have been 18 years ago, there was no doubt in my mind that the lessons being imparted in this book, even though it was about manufacturing, were absolutely relevant to the work that we do. And for a decade, it's been our aspiration to write essentially the goal, but for the technology value stream. And that's what the Phoenix Project is. There are many similarities between the goal and the Phoenix Project, and that's very much by design. We studied that book for a decade, getting ready to write that book. And so one of the similarities is that they both have a Yoda, Mr. Miyagi character who speaks in very difficult to understand ways. And so our Yoda speaks in the language of the 3 ways, which are intended to be the set of principles from which you can derive all the observed DevOps behaviors from that lead to these amazing outcomes, both for dev, test, and operations. And so I want to share with you what those 3 ways are and what some patterns are that you may have seen and maybe some of that you haven't. So the first way is all about flow as you go from left to right in the value stream, from dev to ops. And by the way, that begs this really great question, which is why dev and ops? It's because dev and ops are what's in between our organization and our customers. So in other words, whenever the organization says, here's where we are and here's where we need to go, in general, that creates work that has to get completed by development that must then successfully transition into operations for us to deliver value to customers. And so even though in the DevOps community, our favorite metric is deploys per day. In manufacturing, that's obviously not their favorite metric. Their favorite metric is lead time. And there's this deeply held belief that spans decades that lead time is the most accurate predictor of internal quality, of customer satisfaction, and even employee happiness. And what we found in our benchmarking of 20,000 organizations is that's absolutely the case in the work that we do as well. And by the way, so in manufacturing, they would measure lead time as how quickly can we go from raw materials at one end of the plant to finished goods at the other, right? And the shorter, the better, right? The shorter that lead time, right, the better the quality is, the more happy the customers are, and the happier internal employees are. So in our work, we would measure lead time as how quickly can we go from code committed into the source code repo, through the test pipeline, through the deployment pipeline, actually running in production. And by the way, why do we start there, right? There's many places that you could start, right? Feature accepted and so forth. It's because the code commit time is the boundary between the work that is development, that is highly creative, to where the deployment pipeline begins that should be highly mechanistic and predictable, right? And so how that lead time, code deployment lead time, is the best predictor of not only operational outcomes, right? Because for all the reasons that we stated, but it's also how quickly can developers get feedback on their work, right? So the code deployment lead time is this magical measure because it not only predicts operational success, but also development success, right? And so, the work that we do here, right, is not just great for operations, but it's critical for developers. So we measure lead time, if you go all the way back to, feature requested to actually running in production, right? We know that high performers can do it in minutes, but lower performers would take months. Why? Because, we can't get environments when we need them, right? It takes 6 weeks to get an environment. It takes 6 weeks to get any sort of testing done. It takes, 4 weeks to manually configure environments and make the firewall changes, right? You add all that up, and it might take six to 9 months to make even small production changes. So we know that when that happens, that's highly correlated with all sorts of bad outcomes. But there's another thing that is very highly predictive of. When you have lead time measured in months or quarters, it's predictive of a high degree of distrust between dev, test, and operations. In other words, every deployment event feels like a betrayal, right? Especially to operations, and it doesn't feel so good for development as well. And when we have deployment lead time measured in months or quarters, it's also highly predictive of this: catastrophic deployment errors, right? So if we were to look at the worst deployment outcomes over the last 20 years, in my mind, that's like Toys R Us 1999, Amazon 2001, LinkedIn 2009, healthcare.gov, right? I don't care what your politics are, right? Whenever you see long catastrophic deployment outcomes, in general, it's highly associated with very, very long lead times. And one of the major contributing factors to this is that the first time that we got to see how did the code or the application behave in anything that resembled a production-like environment was during the deployment, right? And so if you believe that, then I think you'll find one of the countermeasures, to be very obvious, right? Is that, in high performers, they make production-like environments available on demand, right? You don't have to wait 6 weeks. You don't even have to open up a ticket. Anyone who wants one can get one, or better yet, it's automatically given to you when you check code into the repo. And so the critical component is that there's some sort of build mechanism that builds the dev, test, and production environments all at the same time. And the best beneficiary of this is, besides the customer, is development, because it means that they're using production-like environments even at the earliest stages of their project. And I think one of the best stories even now of like how dramatic this effect can be is still the Facebook chat story. And this happened in 2008. And so some of you might roll your eyes saying it's a chat server, sounds pretty easy. So you should know that a chat server implemented naively is like an order n cubed algorithm. It was their first use. It was one of the largest technical undertakings that Facebook had undertaken. It took 1 year for them to develop. And so how did they use that year? Every day during that project, they were checking code into the repo. Whatever was in trunk would get silently migrated into the production environment once per day by Chuck Rossi. And moreover, they were using every active Facebook browser user session as a test harness. So every day, users would actually be sending invisible test messages to their Erlang backend server, invisible to the customer. And so when it actually came time to announce Facebook chat availability to everybody, they went from 0 users to 70 million users overnight without a hitch. How? they were testing under production-like loads for nearly a year, right? And so, by the way, just to share with you where I came from, if you had told me 10 years ago that testing in production is good, I would have said that's crap, right? Testing in production are what bad developers do because they hate ops people. They're late because they're lazy, right? They don't know how to plan, right? And they don't care about customer outcomes or quality. And yet I now believe that to be able to test in production is an absolute game changer because you can do amazing things like this, right? Test under production-like loads long before it actually matters. But there's actually another even more astounding part of the story for me, which is that it also mandates that we do production deploys in the middle of the day. Right? And the reason why I think that that's so important comes from Nathan Shimmick. He said, as a lifelong ops practitioner, I know that we need DevOps to make our work humane. In my career, I've worked on every holiday, on my birthday, and even worse, on my spouse's birthday, and even on the day my son was born. Right? So some of you may have been in situations, or have a friend who have been in situations where they also had to do this out of a sense of duty or obligation, or maybe because they didn't have a choice. Right? And so we know that it doesn't have to be this way, right? By creating a continuous delivery pipeline, right, we can do changes in the middle of the day, right? We don't have to work all weekend to make things work, and suddenly ops and dev can work the same work hours, which many of us believe is the way it should be. And so lest you think they can only do this for open source software, right, for the LAMP stack, you should know about this case study that was given to me by Scott Prue. He's the chief architect and head of development at CSG. They're one of the largest bill printing companies in the US. So if you get a paper bill from a cable company, a wireless carrier, chances are it comes from a CSG plant. And so they did an experiment where they started doing daily deploys for their main bill printing operations. So that's a COBOL mainframe app that's 30 years old, and it involves 20 surrounding technology platforms. Right? And so by doing daily deploys and doubling the release frequency, instead of doing deploys only 4 times a year, they went to daily deploys and releasing features 4 times a year. The result was that incident count went down by 90%, lead time went down from 2 weeks down to a day. In other words, it used to be 2 weeks of a war room filled 24/7 of panicked people trying to get things running, right, to the war room being empty by the end of the first day, right? And so it's great for dev, test, and operations. But as Scott Prue corrected me, he said, the real point is that the customer got the value in half the time, right? So it's not only great for dev, test, and operations, but ultimately it's great for the customers that we serve. So let me share with you just one other thought on the deploys per day metric, right? I shared with you the Amazon metric, how they're now doing 136,000 deploys per year. What's interesting to me about high performers is that they have an ever-increasing number of deploys per day. If you look at Etsy, over the years, they went from doing 30 deploys a day to 80 and 90 deploys a day. They're now doing hundreds of deploys per day. The question is, what changed at Etsy that could explain this? And the surprising answer is nothing changed at Etsy except for one thing, which is the number of developers. And so we've had this long-standing hypothesis that deploys per day is actually a proxy measure for an even more important metric, which is deploys per day per developer. In other words, is it true that for high-performing organizations, they can actually scale developer productivity linearly with the number of developers, going against a lot of the common wisdom, which is that if you double the number of developers, we double the testing effort, we double the integration effort, and ultimately double the amount of time required to get code to the customer. And so as part of the 2015 State of DevOps survey with Puppet Labs, we actually tested that. We asked, what is your deploys per day per developer? And what we found was that in low performers, as you increase the number of developers, right, deployment frequency went down. Medium performers, it was flat, whereas high performers would actually increase. So this is a logarithmic scale. So high performers could scale developer productivity linearly with the number of developers, right? And so that is an important metric in my mind, right? There's no technology leader who doesn't care about making sure that we can keep developers productive and scale it as we increase the development workforce. Am I making sense? Yeah. So that was a cool graph. So the outcome of the first way is that we have a single repo for code and the environments. We should have everything in version control, regardless of who we are in the value stream, whether dev, test, or operations. We found that the top predictor of not just IT performance, but organizational performance was this one behavior. Did operations have everything in version control? This was actually a higher predictor of performance than whether dev used version control, right? Why? I think our theory is, where is there more entropy? Is it in the code or is it in the environment? And I think my assertion would be, if you count the number of configurable settings, it's actually orders of magnitude higher in the environment than in the code. right? And so when everything's in version control, if we can roll back, predictably, better yet, make sure that we can feed our changes downstream, upstream into development. This is what causes determinism in the release process. We have consistent dev, test, and production environments all configured correctly and synchronized long before the big deployment. Developers are checking code in daily with the safety net of automated testing. And this frees ourselves from this learned behavior that the deployments hurt, right? We don't have to do them on weekends and clear the decks to work all weekend. We can do them in the middle of the day, right? Synchronizing the work hours of development and operations. And this is what shrinks lead time. If we can do it in minutes versus months, right, suddenly we can actually do them more frequently. And so now we're replicating, one of the classic observed patterns of high performers, multiple deployments per day, or more precisely, deployments on demand. So the first way was all about flow as you go from left to right in the value stream. The second way is all about feedback from right to left. In other words, whenever something goes wrong, how do we create the fastest feedback loop, ideally all the way back to the value stream to developers so that we can ideally prevent bad things from happening again? If we can't prevent it, at least enable quicker detection and recovery. And so I think the paragon of this principle is without a doubt the Toyota Andon cord. And so I spent a week at the University of Michigan getting trained in the Toyota production process, and it startled me to find that it really is true. On the plant floor, on the plants modeled after the TPS, you will find this cord above every work center. And everybody is trained, regardless of what work center they're at, whether they're a plant manager or the regional vice president, if something goes wrong, you pull the cord, right? So that means if the parts are defective, we pull the cord. If the parts aren't there, we pull the cord. If even the work takes longer than documented, it took, supposed to take 55 seconds and it took 1:30, pull the cord. And so what happens when you pull the cord? The entire assembly line stops. So trucks stop coming out the other end. And so one of the big surprises for me was how many times the Andon cord would be pulled in a typical plant, right? In other words, how many Andon cord pulls per day? And the answer shocked me because it's 3,500 times per day, right? And you can imagine my reaction was, these guys are idiots, right? These guys are absolute morons, right? Don't they know that every time we pull the cord, we're actually magnifying a local disturbance and turning it into a global disturbance, right? Don't they know that pulling the cord will actually cause the entire assembly line to stop? And it turns out they do, right? And so the next question becomes, why would they do that? Why do they pull the Andon cord so frequently? And to a T, right, there's a surprising degree of unanimity in their answers. They would say it's because that's the only way that we can sustain a build tempo of 2,000 vehicles per day. So that's one every 55 seconds. So essentially what they're verbalizing is that if we don't pull the cord, we are going to let the defects go downstream, where it will become far more difficult, far more expensive, maybe even impossible to fix. And on the plant line, right, there's actually even a more visceral reason that if you don't fix root cause there or develop some sort of countermeasure, you're going to have the same problem 55 seconds later, right? So, and that happens in the work that we do as well. So in continuous delivery, I think the equivalent of Toyota is Google. They have, in 2013, they had 15,000 engineers as defined by dev, test, operations, information security, working on 4,000 simultaneous projects, right? And trust me, right, of course, there's no spreadsheet at Google with 4,000 rows that's being surveilled by a project management office, right? These development teams are working with a high degree of autonomy and freedom, and more importantly, safety, right? All code is checked into one source code tree, right? Only one library allowed across the entire set of Google properties. They're doing 55 code commits per day. There are 75 million test cases being run daily. And why would they do this? It's not because they have more servers than God does, right? The real reason is that it's the only way that we can transform fear into boredom, right? He said, imagine, Aaron Masseri, who's part of the SCM group at Google, he said, imagine the paralyzing amount of fear any new engineer has at Google, knowing that any code commit they do could take down all Google properties all at the same time, which has happened, right? He said, essentially, the only way that you can get people to hit enter, right, is to show them that there is a safety net underneath them that's going to catch errors long before it gets into production. And so I think that is, beautiful, right, is that testing protects people. By the way, just as a quick comment, this notion of only one version allowed across all of Google is amazing. The opposite of that is a friend of mine. He said, we're at a big bank. there are 81 versions. There's 83 versions of the Java struts library. We are running 81 of them in production, right? Right, so just imagine how hard life is when you have to support 81 versions of Java struts. So another pattern is developers carry pagers. I love this quote from Patrick Lightbody. He said, "We found that when we woke up developers at 2 a.m., defects got fixed faster than ever," right? Werner Vogels at Amazon even says it more succinctly: if you help build it, you must help run it. And so I'm aware that jackasses like me showing slides like this is actually creating a lot of ammunition for developers to hate DevOps. In other words, there's a bunch of conversations I'm sure happening everywhere saying, if you see anyone pushing this DevOps thing, and it's even worse if they have Jenkins running, right? See if you can sabotage their efforts, right? Because we did not become developers to wear a pager, right? Pagers are for ops people, right? They wouldn't be an ops person if they didn't like pagers. So I think that's a valid concern, but I think there's even a more compelling narrative. And that comes from Tim Tischler. He was heading up the DevOps initiative at Nike. And he said, as a career-long developer myself, there's never been a more satisfying point in my career than when I got to write the code, push it into production myself, got to see the smiling customers when it worked, and got to see their angry shaking fists when it didn't, right? And when I could fix it myself. Right? I didn't have to open up a ticket. I didn't have to wait a day for someone else to do it. Right? Not only could I have done it faster, but I could have actually learned something, right? So I could prevent it from happening the next time around. And I think in so many large, complex organizations, we've become increasingly unable to do that. And it's taken a lot of the joy out of technology work. And I think DevOps is what brings it back. This ability to safely push code into promotion, regardless of whether it's done by dev, test, operations, or even information security. By the way, just as a side note, Jez Humble and I, in the State of DevOps report, one of our bets was who would have better outcomes when those organizations were dev deployed or those organizations were ops deployed. So Jez obviously said developers, right? Developers are the only ones that could understand the intricacies of how the code interrelates. And my position was, no, it's got to be ops, right? The complexity is in the environment, not in the code. The surprising answer, what the data showed, was it was the same, right? You take the population of dev deployers and ops deployers, statistically, change success rate, mean time to repair were identical. So apparently, if you have shared goals, it doesn't matter who pushes a button, you get the same great outcomes. So another critical pattern of feedback is this notion of pervasive production telemetry. So this is John Allspaw from the famous Allspaw-Hammond presentation. He's now heading up tech ops at Etsy, who recently went public earlier this year. And there's this culture at Etsy that says if anyone writes code or anyone who puts something in the environment must also create production telemetry for it. Right? In other words, if it's important enough to implement, it's also important enough to understand how it's actually behaving in a production environment. And so it should be, this production telemetry should be written as part of our daily work. And so Etsy went on record in 2011 saying that they were tracking 200,000 metrics per day, right? And this is what happens when people can seamlessly create telemetry without having it feel like doing a database schema change. And so this explains why they put so much effort into building the StatsD and Graphite library, right? This idea that regardless of what code you're writing, what environment you're writing in, you can write one line of code, and then you'll get your 200,000th and first metric, right? And so in this case, it's number of logins successful and unsuccessful, and every vertical line, of course, is a deploy. And so, by the way, in 2011, Etsy was tracking 200,000 metrics in production. Last year, they were tracking 800,000 metrics in production. So this is just another, I think, evidence point that says high performers are always accelerating away from the curve. And there's another tremendous beneficiary of this pattern, which is information security. In fact, if you look at how Capital One is rolling out DevOps, if you look at their name, they don't call it DevOps, they call it DevOpsSec. And I think this is like one of the best embodiments of how we should actually integrate information security into the daily work of development, test, and operations. So we have all the preventive libraries in the source code repos that are already pre-blessed by security. We have static code analysis running right alongside unit testing in the deployment pipeline. We have monitoring happening and security monitoring and doing dynamic code analysis so that we can find issues long before an attacker does. And the reason why I think this is so important is that for 6 years running, they have found whenever there's a cardholder data breach, this comes from the Verizon data breach reports that they do, is that in general, when organizations lose cardholder data, it takes organizations months or quarters to determine they're actually losing cardholder data. For 7 years running, when they ask the question, why did it take so long? The number one answer is always, no one's looking at the log files. Right? So imagine, right, how great it feels for an information security practitioner to know that we are integrating security testing and security monitoring all the time as a part of our daily work, just because that's what the culture demands. There's one last cultural norm I want to share with you that belongs in the second way, which is that of culture. So this is what we found was that the third highest predictor of performance, this IT performance and organizational performance, was organizational culture. This is behind version control and automated testing. This is called the Westrom organizational typology model. So what Dr. Westrom discovered 11 years ago was that one of the highest predictors of patient safety in healthcare organizations was how organizations, where did they fit? Low performers, he called, they had pathological cultures. We hide information, messengers of bad news are shot, we discourage sharing responsibilities, so that in their world it was nursing, patient intake, ER, pharmacy, and so forth. We cover up failures. Why? Because messengers of bad news are shot, right? And we crush novel ideas. In the middle, we had bureaucratic cultures, but at the highest performers in patient safety, what he found was generative high-trust cultures. We train messengers to tell bad news. And by the way, this absolutely was the case in DevOps as well. This was the third top predictor of performance. In other words, we found in high performers, we train messengers to tell bad news. We might even train everybody to lead blameless postmortems when something goes wrong, right? Because that's actually one of the best ways to create organizational learning to prevent, detect, and correct faster. We share responsibilities. In other words, uptime and availability is not just ops' job, it's all our jobs. Same with information security, right? It's not just information security's job, it's something that we all share in the value stream. This requires that we bridge between teams, and when failures happen, it causes a genuine sense of inquiry, right? And we are open to novel ideas no matter how crazy they seem. And why is that? I think it's because if the solutions were obvious, they would have been fixed already. And so I think how organizations transform from low trust cultures to high trust cultures is the grandest management challenge of our decade. Because so many organizations, we are living in organizations that have decades or maybe even over a century of a command and control, low trust bureaucratic culture. So we know that DevOps requires high trust cultures, and there's no community better suited to solving this problem than this community. There's one, I think, very tangible way that this manifests itself in large, complex organizations for the work that we do, which is change control. And so one of the most startling conversations and discoveries I've had in my professional career was this conversation I had with John Allspaw and Jez Humble around how Etsy does change control. John Allspaw told a story that described how a new junior engineer, and in fact it was like an HTML engineer on the first week of his job, asked John Allspaw, is it okay for me to make this production change? To which John Allspaw responded, I don't know, is it? In other words, Allspaw refused to own any of the responsibility of the quality of the change. He put it all back squarely on the shoulders of the implementer. So Allspaw's questions in response was, did you get someone else to review your change? Do you know who the subject matter expert, is for, who's the best person to ask for a change of this category? Did you do everything that you could to give yourself confidence that this change is going to go into production and operate as designed? If you did, make the change, right? And I think this is so different than how large, complex organizations in the last decades, have developed change approval processes, right, that involve ever-increasing number of forms in the change request form and ever-increasing number of signatures required to go into production. Am I making sense? Yeah. So I think it is probably a safe bet that those days of requiring change approvals for every change is probably coming to an end. So the outcomes of putting the second way into place include peer review of not just code changes, but environment changes. Is for ops as well as dev. We have automated discipline testing that's allowing small teams to work with autonomy and freedom and safety, because if we compartmentalize, if we have loosely coupled code bases, that means that small failures will create small compartmental failures. They won't cause global catastrophic failures. We have proactive monitoring of the production environment so that we can detect and correct issues quickly. We have security defects and operational defects getting fixed faster than ever. We have a high-trust culture that allows all groups to communicate and coordinate better, which leads to something that we all care about, which is that everyone's getting more productive work done. So the first way was all about flow from left to right. The second way is all about feedback from right to left. And the third way is all about fostering this culture of high trust and learning, of constant experimentation and learning. I think in our community, the person who verbalizes it best is Adrian Cockcroft, who is famous for many things. Most recently, he's famous for the work that he did transforming the Netflix video delivery infrastructure from a J2EE app that was monolithic and ran in a data center in 2009 to one that runs entirely in the Amazon public cloud. And he's said many famous things, but the phrase that I love is this one. He said, "Our goal is to do painful things more frequently so that we can make it less painful in the future." So even though we make life hell for developers at times, the reaction we get from them is, "Thank you. Thank you so much, because we know doing this will make our life better in the future." And I believe that the best evidence for the effectiveness of this philosophy in practice is still, without a doubt, the first 2011 massive AWS outage, where essentially almost every AWS customer went down. Why? Because AW East went down, right? So everybody went down, Reddit, Quora, and so forth, except for one very curious exception, right? And we know who that is. It's Netflix. And so for those of you who remember that on April 21st, 2011, when everybody went down and Netflix stayed up, we were all wondering, what is it that Netflix is doing differently that resulted in such a different outcome for them? And I think the leading theory, of which I was a proponent of, I must admit, is it's obvious. It's because Netflix is Amazon's biggest customer, and so clearly they were given some sort of secret flag called "Do Not Crash," right? It turns out that was not the answer. The real answer was revealed about 3 weeks later, when they put out this now famous blog post that essentially revealed two design decisions that they had made very early on. The first was that there can be no single point of failure, of which Amazon is one of our largest. They essentially were verbalizing, Amazon will never be there for us when we need them most. And secondly, they said, in order for us to survive failure, we're going to have to fail all the time. And so that's, of course, when they unveiled the now famous Chaos Monkey, right? This incredibly audacious piece of code that runs on every production server, and it randomly kills processes, kills entire compute instances in production. And so you can imagine how quickly you end up with more resilient environments and resilient code when you do this in production. So there are two things that I'd like to share with you that Adrian doesn't talk about a lot, but he should. The first is, before you run Chaos Monkey in production, you should first run it in test, right? Because they did. The second thing, which I think is even more astonishing, is this. Did you know on that day, April 21st, 2011, Netflix went 6 hours into the AWS outage before declaring a Sev1 incident? In other words, every hour they would convene and say, should we declare Sev1? Should we activate some business continuity procedures just in case? And their conclusion was always, no, it will probably come back. It usually does, right? Only 6 hours later did they determine maybe it's not coming back, right? Maybe we should take some steps to make sure that we can resume normal operations just in case if it doesn't. And so the reason I want to share that with you is because on that day, April 21st, in that sea of chaos and confusion, Netflix was a strange island of calm, right? And I think that's the reward when we test fearlessly, faults in production. And a more contemporary example happened earlier this year, actually last year, in the great Amazon reboot of 2014, when 10% of the entire server fleet was rebooted to apply a security Zen patch. Christos Kalantzis at Netflix said, when we got the news of the emergency reboots, our jaws dropped, especially when he looked at the number of Cassandra nodes that were affected, where all their production data was being stored. He said, I felt physically ill. And then he went on to say, but then I remembered we've been running Chaos Monkey for years. Bring it on, right? And so what was the outcome? Out of their 2,700 production Cassandra database nodes, 218 rebooted, and 22 didn't even come back up again, right? They bricked 22 Cassandra nodes. I get physically ill just saying that, and yet customers experienced no downtime. I learned 6 months ago from Roy Rappaport, apparently not only were they not on call, they were not even in the office. The entire Netflix organization was in Hollywood, California, celebrating the acquisition of their 1 millionth customer, right? So not only were they not on call, they were at a party. So again, this is the reward of fearlessly injecting faults into the production environment. So there's one last practice I want to share with you in the third way, which is this. This comes from Marty Kagan. He's a hero in the product management space. He has trained a generation of product managers how to be great product owners. He wrote a phenomenal book called Inspired. So he was the VP of product management at eBay in the early 2000s. He said the one lesson that he learned there was that we must pay 20% tax to pay down technical debt. In other words, a generation of product owners has been taught by Marty Kagan to say 20% of all dev and ops cycles should be taken off the table. They're not there for product owners to spend. They are there for ops and dev to use however they best see fit to fix problematic areas of the code, automate the deployment pipeline, to refactor or re-architect the environment to make code deployment safer. The reason is, he said, you never want to be in a situation where you leave technical debt running to the point where it becomes unsafe to deploy code. So in other words, if you don't pay your 20% tax paying down technical debt, you are destined to pay 100% of your time paying down technical debt. And that's what happened at eBay. He couldn't ship a new feature for 2 years. So if we can mobilize that coalition, to fix technical debt that spans the dev, test operations, information security, and even the product owner community, that's how we can go from a situation that looks like this, that eventually goes to a situation that looks like this. If we can fix those things that cause us problems, that's how we go to a situation that looks like this. By the way, this is a picture of the DNS serving infrastructure at VeriSign in Western Virginia. And this is probably a $60,000 cabling job, right? But they would never blink an eye at paying that price because they know that the price you pay to deliver world-class service, right, is something like this. You can't be available, right, when the entire data center is a mess. And so too, right, for organizations that want to deliver great code and deliver great service, operational service, we should never flinch at paying that 20% tax. So the last thing I want to leave with you is what I've learned about how large, complex organizations are adopting DevOps patterns. In other words, DevOps is not just for the unicorns, but it's for the horses too. And so that desire to answer that question of how are large complex organizations transforming was the reason that we held the DevOps Enterprise Summit last October, and we're actually holding the second DevOps Enterprise Summit in October 19th to the 23rd. And so the goal was to take leaders of organizations that are leading DevOps transformations in large complex organizations and essentially get them to give experience reports. And so every speaker said, here's something about the organization, here's a business problem we're trying to solve, here's what we did about it, and here were the results. And there were no 3 days where I've never had 3 days where I've learned as much as those 3 days. I want to share with you what my top 2 surprises are. One is those organizations like Target, Verizon, Raytheon are employing the same sort of cultural patterns and technical practices and the same tools, and they're getting the same sort of miraculous outcomes that the unicorns are. So Target is doing 10 deploys a day with fewer than 10 incidents per month as a part of daily operations. What are they doing it for? They call it the API enablement team. So the business problem that they were trying to solve was every time a new dev team wanted to access store catalog, create orders, cross shipments, get data on stores, they would often have to wait 6 to 9 months for the system of record teams to get ready. So the goal was to move all that into a next generation system of record that's in the Cassandra cluster, right? And they're doing 10 plus deploys per day. Capital One is created as part of their shared service, a Jenkins delivery pipeline, where they're doing hundreds of deploys per day with the lead time measured in minutes, right? That's obviously through code check-in, through the test cycle, through the deployment cycle, successfully running in production. Macy's, Gary Grufer, the head of operations for Macy's.com, described how they were going from a situation where they were running 1,500 manual tests every 10 days to running hundreds of thousands of automated tests per day. Nationwide Insurance, they did this not for some hippie, open source software. They were doing it for what they call the state pension retirement funds, a 30-year-old COBOL mainframe app. And Raytheon, they were doing testing and certification for ground control stations for satellites, from taking the testing and certification time down from months down to a day. And so, if you can do it for these type of stodgy old applications, I think that should give us confidence that the techniques that we are using not just for open source software, is also equally applicable for anything technology related. The last observation and learning for me was this, is that I think the stories told during those 3 days were among the most courageous I've ever heard of. In other words, if any of these leaders had described these transformation stories at a Google or Amazon and presented at the Velocity conference, I think our reaction would be, yeah, that's what we expect. You know, that's what Amazon and Google does, right? And yet, I think these leaders were doing these transformations in organizations that had decades or maybe over a century of bureaucratic command and control cultures. And so I think each one of these leaders were given some degree of air cover, but I think every one of them wildly exceeded the air cover they were given. So essentially that would put them into positions of some amount of personal jeopardy. So why would they do that? Well, I think what all the speakers shared was a sense of clarity and conviction that the capabilities they were developing for their organization was needed for them to not only win in the marketplace, but was required to even survive in the marketplace. And so I think this should validate that the work that you're doing here in the Jenkins community is important. And there's no better testament in my mind than the stories of people pushing these transformations. So why do I think this is important? Because left unchecked, without something like DevOps and continuous delivery, leads to horrendous outcomes, not just in development, test, or operations, it's information security, and ultimately the entire organization that we serve. And how much economic value is there on the table for us if we can solve these DevOps-like problems? A friend of mine, we did a calculation. This is Mike Orzen. He's a Shingo Prize winner. It's the most cherished prize in the lean manufacturing community. We asked this question, and we calculated if we could just have the amount of waste in the value stream, in the technology value stream, and redeploy it in a way where we get 5 times the value back, we could create $2.6 trillion of economic value per year, right? And just to calibrate that, that is equal to the economic output of France, right, the 6th largest economy. So imagine if you can put $2.6 trillion back into the economy over decades, right? Suddenly a whole category of problems suddenly becomes solvable. So I think the work that we're doing is important, and the work matters. So if you're interested in learning more, if you want slides and videos from the DevOps Enterprise Summit from last year, if you want information on the DevOps Enterprise Summit coming up in a month, if you want excerpts from the Phoenix Project audiobook, if you want to see early drafts of the upcoming DevOps cookbook, all you need to do is send an email to realgenekim@sendyourslides.com with the subject line of DevOps. So don't take a picture, just pick up your phone and send an email to realgenekim@sendyourslides.com with the subject line of DevOps, and you'll, within a minute, get an automated response with all these resources. So thank you so much. KK, thank you so much for allowing me to be a part of this, and looking forward to seeing you for the remainder of the day.